and have a self-supporting dome for a building, which would be a sculpture at the same time. In almost all the shapes, you need precision somewhere, but you don't need it everywhere. You need precision at the points where things fit together, but you don't usually need it all over the place. If you can imagine enormous panels that would have to fit to very precise dimensions on the outline and would have, for some reason, stiffening members, you could produce the outline on a die and put the stiffening members free-form, and each one could be different. They would still correspond to the same function, and the application in architecture could be just fantastic. The dome is a part of the sculpture that will be put flat in the concrete right between the three vertical pieces, and it would act as a mirror. It will be reflecting all the three pieces, like those old mirrors that you use in America. In the States, you had the old mirrors from 18th century that were dome-shaped.
The two blanks were prepared by polishing with a special machine to a very high polish, and were later placed on a die and formed two at a time in one shot. Pete's created a sculpture, and he's relying on a scientific object to cast light on it as the sun moves it.
Well, I wanted this sculpture to be related very directly to space. It could be felt by anybody who looks at it. An object in space with which we live all the time is the sun and the light of the sun. That's why I thought of using the sun as a homing object for this piece of sculpture. I feel it's a wonderful coincidence that El Toro is producing parts for the moonflight, art that should reflect it in some way, especially here, where space is so important. There's no limit to size that the explosive forming can do in forming metal. We can get metal of any size, and we can get as much explosives as we want to form it. Now, those pieces are 22 feet long, and the only limitation we had were the size of pits that we had at El Toro. If we had larger pits, we could do larger sheets. The pits there were 25 feet in diameter, so that was our limit. So, if we took a piece of metal in the sea, where we have all the water that we want, we would be able to form pieces of metal of any dimension. Now imagine if one day, and we can do it right now, we can take any sheet of metal, any size, put the charges on, hang it from the helicopter, bring it out into the sea, lower it down and shoot it there, bring it up ready. We'll be able to form hulls of ships entire, I think. Airplane wings, cladding of buildings of any dimension. We'll be able to form them free like this. Just energy applied with a calculated know-how, forming the metal into shapes we design. This is the mirror that will follow the sun and will shine the light in and on the sculpture. The light that will go in will bounce around. The whole idea of the sculpture is a question of light and mirrors. We have this mirror here that will follow the sun with a heat-sensing device, and we'll focus on it all the time. and the angle of it is so calculated that the sun will be shining on it most of the year. Over there we have stable mirrors, 3 22 feet high stainless steel convex and concave forms. And in the center here we have a little dome that will reflect the whole sculpture. Those pieces will be very highly polished, like this one over here, so they will exist more as light than as weight or form. Now the light here will bounce as much as the sound bounces now. There is an echo, continuous echo in here, and the light will do the same thing. Pick up from the mirror, bounce on one piece and go to the other and go back and forth. This is 1/4-inch stainless steel. It's very thin compared to the height. And as you can see, this will tremble with the wind and move. Yet it's very strong.